Hello students, a very good morning to all. Now I have again going to continue with my lecture, that is PD partial differential equation. This is the fifth lecture. Let me tell you what type problems I am going to solve in this lecture. These only in this lecture I am going to solve here two problems, that is ninth and 10th. After that one lecture I will complete these four problems, right? So let's see here the problems we have. First one, let me tell you the previous, yes, for ninth problem, right? We have ninth problem here, that is, now this yellow will work better, right? Now this is, we have xzp, xzp plus yzq, yzq equals to, we have what, let me tell you, that is xy. We have xy. Now we have to solve this problem at the solution. Solution is what we have. First of all, we have to comparing with the Lagrange, Lagrange's PD partial differential equation, right? This is, we have capital P small p plus capital Q small q is equal to R. Now the actual equation for this PD we have actual equation for this PDF dx upon capital P, that is dy upon capital Q is equal to dz upon capital R, right? So we have dx upon capital P, the value of capital P we have xz is equal to dy upon capital Q, that is yz, equal to dz upon R, the value of R we have xy, right? So now we have to solve this problem, right? So this is the first one, this is the second one, and this is the third one. I am taking first and second, right? So we have dx upon xz is equal to dy upon yz. Now you can see this z cancel, we have dx upon x, that is dy upon y, right? Now integrating, we can write here 1 upon x dx integration 1 upon y dy. This is what, log x log y plus log c1, right? So this is what you can say, this is log x minus log y is equal to log c1. Now you can use the formula, we can write here log x upon y, right? Log c1. Now take the anti-log. After taking anti-log, you can write here x upon y is equal to c1. This is equation. Okay, now see, now I am taking here second and third. Second and third, that is we have dy upon yz is equal to dz upon what we have, xy. We have or not? Let me tell you. Yes, dz upon yz upon xy. Right? So in this case, this y and y will cancel. So we have dy upon z equal to dz upon x. Now there is a problem, because we can adjust z to dz, but how this is x is disturbing us, right? So now we will use equation 1 from the previous slide. Right? Yes. So we will use here equation 1, right? X upon y is equal to c1. So x is equal to c1y. X equal to c1y, I can write here. C1y, right? And this is clear. Okay. So now we can solve easily. This is c1y dy, right? This is z dz. So c1, now the y dy integration y dy integration z dz. We have c1 into y square by 2 is equal to z square by 2, right? I am adding here constant capital N, right? So this is c1 y square minus z square, right, is equal to, I am writing c2, because yes, c2 is equal to what, 2a. So now this I can write the value of c1 we have, how much we have, x upon y into y square minus z square equal to c2. So we can write this y cancel, we have xy minus z square equal to c2. This is equation second. Now the solution is what we have, phi of, right? Go to the previous one. We have first equation, we have x upon y minus c1, x upon y, right, comma. Now go to the equation second. We have xy minus z square, xy minus z square, right? So this is the solution. So now problem is solved. Now we come to the next problem, that is 10th. We have here 1 plus x, I think this, I will check. 1 plus, let me check. 1 plus yp plus 1 upon xq is equal to z. 1 plus y p plus 1 upon x q equal to z. This is the problem we have. So again solution. Now compare with the Lagrange's PDE, means partial differential equation, right? And this is what we have. And think, let me tell you, this is we have dx, sorry, capital P small p plus capital Q small p is equal to r, right? So we have dx upon capital P is equal to dy upon capital Q is equal to dz upon capital R, right? This is what auxiliary equation. So I will use this auxiliary equation to solve the problem, right? Now, so we can write dx upon capital P means we have 1 upon y is equal to dy. We have capital Q, that is we have 1 upon x is equal to we have dz r, we have r. Now go to the previous. Now you can check here, capital P 1 plus y, capital Q 1 plus x, this is capital Q, this is capital P, and this is r, this is r. So, right? So now this is the first fraction, this is the second fraction, and that is the third one. Let me take here first two fractions, that is dx upon, let me solve the problem, that is dx upon 1 plus y dy upon 1 plus x. This is we have. Now how can you solve that? This problem is simple. We can write here 1 plus x dx, that is 1 plus y and dy, that is we have, right? So in this case just integrating it, 1 plus x dx integration 1 plus y and dy here, right? So we have integration, that is 1x, x कितना होगा, x square by 2, that is minus I can write y plus y square by 2 is equal to c1. This is the question 1. It's very simple, right? So now we form equation 1. Now I will use the concept of multipliers, because I have to deal another, we need one more equation to write the solution of this problem. So we have, in this case because we have to just use the multipliers. Here you have to move, just use the multiplier in such a manner that this whatever we have in the, listen carefully, in the denominator, that will be the exact depreciation of the where numerator, right? So I can write here, I am choosing here, let me tell you in the next slides. Dx upon we have 1 upon y, we have dy upon 1 plus x, we have dz upon z. So I am taking here p1 dx plus q1 dy plus r1 dz. This is what p1p plus q1q plus r1r. Now what are p1? I am taking here p1 equal to 1, q1 equal to 1, r1 equal to 1, right? So you can write in this expression, that is we have d of x plus y plus, we can take d common, right? P1 P1 upon, that is p1p, we have 1 plus y, we have 1 plus x, we have z. So in this case I can write here d of x plus y plus z upon, let me tell you first of all, then I will write, complete the numerator, right? Now in this case, in the denominator, we can write here x plus y plus z plus 2. right? So now I am adding plus 2 here in the numerator. Why? I have to make the exact differentiation. Listen carefully. I have to make the exact differentiation of the denominator. Denominator we have x plus z plus 2, right? So the same, if you are going to differentiate, you get the same thing, right? So now I am just taking with you can do, right? We can taking here third and fourth. This is the fourth fraction, this is the fourth fraction, right? So I am going to take here third and fourth. So third is this and fourth is what? We have d of x plus y plus z plus 2 upon sorry x plus y plus z plus 2. Now you can write here. Now you can write here, ये जो भी लिखा है इन दिस केस न्यूमरेटर फॉर फ्रैक्शन, उसका जस्ट नीचे लिखा है, जैसे हम लोग यहाँ पे करेंगे सेम थिंग. यू कैन से, यू कैन इमेजिन दैट दिस जेड इज दिस, राइट? सेम थिंग आपको ये जो लिखा है इतना, वही नीचे लिखा है. जैसे आप लोग क्या करते हो, हाँ अभी पढ़ा होगा मीन्स आप लोग ऐसे करते हो डी एक्स अपॉन एक्स, राइट? सो ये और ये सेम रहता है. जब आप इंटीग्रेशन करोगे ऐसे तो क्या आएगा, लॉग एक्स आएगा. सेम ऐसे ही मुझे यहाँ पे यूज करना है कॉन्सेप्ट, राइट? नाउ वी हैव टू इंटीग्रेट इट, राइट? सो वी हैव हियर log z, then we have log x plus y plus z plus 2. I am taking here log constant, I can take here, that is c2. So this is where I can write here log z minus log x plus y plus z plus 2, that is log c2. This is log m upon n, that is x plus y plus z plus 2 is equal to log c2. So and take the anti-log, so we have z upon x plus y plus z equal to 2 equal to c2. This equation second. Now write down the solution is pi of first equation. We have x plus x square by 2 minus y times y plus y square by 2. So we have here x plus x square by 2 minus y plus y square by 2, then put comma, we have z over x plus y plus z plus 2. So this is our solution, right? This is our solution. If you have any problem regarding this, then you can just reach out to me. I'll be just clearing your doubts. Okay, so till then, bye bye, have a good day and God bless you all.